Today we are working on reviewing expressions, equations, and inequalities. Our I can statements for today: I can expand, simplify, and factor expressions. I can solve two-step equations and inequalities with positive and negative integers, fractions, and decimals. I can write equations and inequalities for word problems, and I can graph inequalities. So we're going to go ahead and start by just talking about expressions. Equivalent expressions are ones that have the same value. So, example, 5 plus 3 and 8 are equivalent. 5 plus 3 means the same thing as 8. 2x minus x and x are equivalent expressions. To find equivalent expressions, you can combine like terms. Like terms means the same variable and the same exponent. So some examples: 3x and 2x are like terms. They both have the variable x. Unlike terms, 5x squared and 2x, the exponents are different. Like terms, w and w divided by 7. Unlike terms, 6a and 6b, the variables are different. Like terms, 5 and 1 and 8/10, they don't have variables at all. Unlike terms 3.2 and n, only one of them contains a variable. All right, so distributive property. We can think about distributive property representing a dinner for my family of 3. So if I'm going to Taco Bell and I want to buy 3 combo meals, each combo meal has 2 tacos plus 1 drink. And I'm going to buy 1 for each of the 3 people in my family. So when I buy 3 of these combo meals, I end up coming home with 6 tacos and 3 drinks. That 3 in front of the parentheses gets multiplied by each part inside of it. 3 sets of 2 tacos gives me 6 tacos. 3 times 2 is 6. 3 times 1 drink gives me 3 drinks. Same is true with the variables as well. 3 times 2t gives me 6t for 6 tacos. 3 times d means 3d. A variable that doesn't have a number in front of it, doesn't have a coefficient, means just one of those things, like 1 drink. All right, so let's take a look at a problem here. Which expressions are equivalent to -3 minus 7.5 plus 4? All right, so we're going to just look to see which ones mean the same thing. When we have this minus sign in front of the parentheses, that minus sign gets distributed to everything that's inside the parentheses. It's like multiplying everything times a -1. I could do boom, change to addition, and boom, change the sign, and make that times a -1. So it's like -3 plus a -7.5 plus a -4. Ooh, I said -7.5 and I didn't write it. -7.5 plus a -4. Okay, so when we use distributive property, we saw that this means really all 3 values are negative. We need to see which other ones mean the same thing. All 3 values are negative. Now we could solve the problem all the way to get an answer, but we don't really have to on this one. All right, let's see. Nothing in front of these parentheses to distribute, so we could just ignore them. +7.5, +4, -3, because the -3 is like a -3. Nope, that's not going to work. There's a negative in front of the 7.5, and a negative in front of that 4 goes with both of them. And then there's a -3, so that one works. Okay, let's see here. We have a negative that would go with the 7.5 and a negative that would go with the 4. But we don't have a negative on the 3. It's a +3, so that one's not going to work. Let's see. Over here, we have that minus sign that would go with the 4. And the 7.5, the 3 has a -2. So all 3 terms on this one are going to end up being negative. So that one works. Now here, this negative goes to the 3. It makes it a -3. But if I did a negative times a -7.5, it ends up becoming a +7.5. So that doesn't work, plus this 4 has a positive in front of it. So nope, that's not going to work. All right, let's see. -3, -7.5, and a -4. that has negatives or minuses in front of all the terms. Yep, that works. And then this one has a negative, and then a plus sign. So that one's not going to work. So on this one, it's B, D, and F that are the ones that are equal to the expression up there. If we simplified all of them, they would have the same final answer. All right, let's look at this one. Which expression is equivalent to 1/4 times the quantity 8 minus 6x plus 12? All right, so times 1/4 is like divided by 4. I'm going to distribute that 1/4 times the 8, 1/4 times the 6, and 1/4 times the 12. And then I'm going to see which one of these expressions it's going to be equivalent to. All right, so let's see. I'm going to go ahead and just do my multiplication off to the side. 1/4 times 8, and I'm going to write it as 8 over 1. I'll go ahead and just multiply straight across. I get 8 over 4. 8 divided by 4 is 2. So 1/4 times 8 is 2. Okay, now I'm going to do 1/4 times negative 6x. That minus 6 is like a negative 6. 1/4 times negative 6 over 1. And then when I write my answer over here, I'll just write the x with it. So that's going to give me negative 6/4. Let's go ahead and simplify that fraction. So if I divide those by 2, I get negative 3/2. So I have 2 minus 3/2, or negative 3/2, same thing, x, plus, and then 1/4 of 12. 1/4 times 12 over 1 gives me 12 over 4. And 12 divided by 4 equals 3. All right, go ahead and take a look at the answers here. We don't have any that exactly match just yet. And that's because we have like terms that we can combine. We've got this 2, we've got this 3. This minus goes with the 3x, the 3/2 x. If I did boom, boom, and made this a plus negative, that goes with that x. That doesn't go with the 2. We have a positive 2 and a positive 3. When I add those together, I get negative 3/2 x plus 5. 2 and 3 are like terms, so I can combine them. So D is going to be my answer for this one. All right. Go ahead and pause the video and try this one on your own. Okay, let's check our answers. We're going to distribute that negative 2.5 to the 1 and the negative 2, and I'm going to go ahead and just do a boom, boom, make that a negative 2. Negative 2.5 times 1 is negative 2.5. Plus negative 2.5 times 2 times negative 2. 2.5 times 2. 5 times 2 is 10. 2 times 2 is 4, plus 1 is 5. 1 decimal in the problem, 1 decimal in the answer. Same signs, negative times a negative. Answer is going to be positive. So I have positive 5n, and then minus 1.5n. Okay, let's see. Like terms, 5n and my negative 1.5n are like terms, but when I do the subtraction, I do need to line up those decimals. And I will need that placeholder 0. I got rid of it when I wrote it over here, but I just added it back in. 0 minus 5 takes me into the negative, so I've got to borrow from the 5. That'll be a 4. This will be a 10. 10 minus 5 is 5. Bring down the decimal. 4 minus 1 is 3. So I have negative 2.5 plus 3.5n. Let's see what things mean the same. Negative 2.5, yep, minus 3.5n. No, that's like a negative. Minus, this is a plus. So no, not A. Negative 2.5 plus 3.5n. Yep, that works. Negative 2.5 minus 6.5n. Nope. All right, D, negative, both start with negative 2.5, so maybe. But we have to figure out this distributive part. So if I do boom, boom, this becomes a negative n. It's like negative 1 times these things, negative 1n times these things. Okay, so 5 times negative n would be negative 5n. Let's see, negative 2.5 plus negative 5n. Negative times a negative is a positive, so it's going to become a plus 1.5n. Okay, when I add negative 5 plus positive 1.5, different signs, find the difference. I subtract like I would here, but here I have more negatives. So I'd get negative 2.5 plus negative 3.5n. This is positive, this is negative. Nope, that doesn't match. This is a positive n. Negative 2.5 plus 5n minus 1.5n. We combine like terms, we get to the same thing we had here. So B and E will both be equivalent expressions. All right, let's take a look at this next one. A garden is 15 feet long by 5 feet wide. The length and width of the garden will each be increased by the same number of feet. This expression represents the perimeter of the larger garden. X plus 15 plus x plus 5 plus x plus 15 plus x plus 5. Which expression is equivalent to the expression for the perimeter of the larger garden? Select all that apply. Go ahead and pause the video. Put down what you think. Okay, let's go ahead and combine some like terms and see what we get. So if I do my like terms here, I have x, 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 x. So I have 1, 2, 3, 4 x's that are all like terms. And then I have 15, 5, 15, and 5. 15 plus 5 plus 15 plus 5. Okay, so here I have 4x plus 15 and 5 is 20 plus another 20 is 40. So my simplified expression is 4x plus 40. Let's see which other things mean that same thing. Okay, well, the first one, 4x plus 40, that directly says it. Let's see what other things mean the same thing. Here I would have to distribute 2 times 2x is 4x. 2 times 20 is 40. So that one also works. Now here I have 2 sets of things being multiplied. I have x times x. That's going to give me an x squared. So that one's not going to work. This one also has x in parentheses times an x in parentheses. That's also going to be an x squared. It's not going to work. Let's look at this last one. 2 times x would be 2x. 2 times 15 would be 30. Plus 2 times x is 2x. 2 times 5 is 10. 2x plus 30 plus 2x plus 10. Yeah, that does simplify down to 4x plus 40. So my correct answers on that one are A, B, and E. All right, let's take a look at this one. Which expressions are a factor of negative 48 x, y, z minus 24 xy plus 40 xyz? Select all that apply. Okay, so this means what could go in evenly to all of these different things. Okay, so let's see, 4. We're thinking about, can 4 go into 48, 24, and 40? Yes, they're all divisible, evenly divisible by 4. So yes, that could be a factor of that expression. 24. 48 divides evenly by 24. 24 divides evenly by 24. And 40. So don't know about that one. That's not going to work. Okay, let's take a look at this next one. 3 and an x. So let's see. 3 goes into 48. 3 goes into 24. 3 doesn't go into 40. Remember to check with if something's divisible by 3. You can always Add the numbers together. 4 plus 0 is 4. And if the total is divisible by 3, then the whole thing is. So 3 does not go into these, so that's not going to work. 8 and a y. Okay, let's see. 8 goes into 48. 8 goes into 24. 8 goes into 40. So the 8 part works. Is there a y in all of them? Y, y, y. Yes, so 8y is good. All right, 2xy. 2. Yes, all of these things can be divided by 2. xy, 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 so that one works. 6xy. 6 goes into 48, goes into 24. 40 does not divide evenly by 6, so that one's not going to be a factor. xyz. This has an xyz, but this one only has an xy, so that's not going to be a factor. So A, D, and E are all answers for this one. All right, let's go ahead and look at this next one. All right, so for equations, we combine like terms. So if you can, before you solve, that's always your first step. Then we do order of operations backwards. So we add and subtract first. Then we multiply or divide to isolate the variable. Then we put the answer back into the equation to check it. All right, so let's go ahead and take a look at this one. Jessica rented 1 video game and 3 movies for a total of $11.50. The video game costs $4.75 to rent. The movies cost the same amount each to rent. What amount in dollars did Jessica pay to rent each movie? Okay, so it doesn't say directly that we have to use an equation, but it's one that lends itself well to solving with an equation. So let's go ahead and try it. The total here what it's going to be equal to. It's going to equal $11.50. We're looking for the cost for the movies. That's going to be my variable. And it's being multiplied by 3. There are 3 movies that were rented. Only 1 video was rented, and it was $4.75. So $4.75 times 3M for whatever the movies cost altogether equals $11.50. Okay, so now to solve this equation, we're doing order of operations backwards, which means we get rid of addition and subtraction first before we multiply and divide. So we're going to start by subtracting $4.75 from both sides of the equation. Make sure you're lining up your decimals. Okay. 0 minus 5 takes me into the negative, so I'm going to have to borrow. 10 minus 5 is 5. All right. I have you 4 minus 7 takes me into the negatives. I'm going to borrow from the 1. It's going to be a 0. This will be a 14. 14 minus 7 is 7. Bring down that decimal. 10 minus 4 is going to be 6. So I know that the 3 movies are going to be $6.75. Now I'm going to divide by 3. All right. So $6.75 divided by 3, I'm going to do it off to the side, $6.75. Divided by 3. 3 goes into 6 2 times. 3 times 2 is 6. I get 0. I need to bring up that decimal point, bring down that 7. 3 goes into 7 2 times. 2 times 3 is 6. We subtract to get 1. We bring down our 5. 3 goes into 15 5 times. So the movies cost $2.25. If I want to check it, I can always put it back in. 3 times $2.25 gives me $6.75. And then adding on that extra $4.75 takes me to the total of $11.50. All right, let's try this next one. Rebecca buys some scarves that cost $5 each and 2 purses that cost $12 each. The cost of Rebecca's total purchases is $39. Which equation can be used to find N, the number of scarves that Rebecca buys? All right, so let's take a look to see what my keywords are that are going to help me with my equation. In a story problem, is often where that equal sign is going to be. Is $39. Now, all of these equal $39, so that's not very helpful in terms of this particular multiple choice one. The thing that's different is where the variable n goes here. So let's see. N is the number of scarves. So I got to go back up here. Scarves are $5. So 5 has to go with the n. All right, and then 2 purses that cost $12 each. Now, I don't see the number 12 here, but I know that if I'm buying 2 purses and they cost $12 each, I can do 12 times 2, and I'm going to get 24 for my purse cost. So n was my number of scarves. It's got to go with the 5. That's how much each costs. So 5 times my scarves plus the $24 for the purse equals the $39 that Rebecca spent. All right, let's take a look at part B here. Megan buys 3 bracelets and 3 necklaces. Each bracelet costs $5. Megan pays the clerk $40 and gets $4 in change. What is the cost in dollars of one necklace? Go ahead and pause the video. Try this one on your own. All right, let's check it. So for this one, 3 bracelets, 3 necklace, each bracelet is $5. Megan pays the clerk $40 and gets $4 change. What is the cost in dollars of one necklace? Okay, there's a lot of information here. So the first thing we need to know is how much money she spent. So 40 minus 4. She spends $36 is how much money she spends. Our equation is going to equal 36. She buys 3 bracelets and each one costs $5. So if we do 3 times 5, I know she spent $15 in bracelets. I don't know how much the necklaces are. That's what they're asking me. So I'm going to do 3 times n. 3 times the necklaces plus the $15 in the bracelets equals the $36 she spent total. All right, so we're going to do order of operations backwards. We're going to get rid of addition and subtraction first. We're going to start by subtracting 15. 15 minus 15 is 0. It leaves me with 3n on the side of the equation. 6 minus 5 is 1. 3 minus 1 is 2. 3n equals 21, and then we are going to divide by 3. And we get $7. So each necklace costs $7. All right, let's take a look at this next one. Devin exercised the same amount of time each day for 5 days last week. His exercise included walking and swimming. Each day he exercised, he walked for 10 minutes. He exercised for a total of 225 minutes last week. What is the number of minutes Devon swam each of the 5 days last week? All right, let's get this equation set up, and then you're going to have a chance to work on it on your own. They tell us our total. That's what our equation is going to equal. It's going to equal 225 minutes. Okay. 5 days last week, and each day he exercised, he walked 10 minutes. Whoa, my pen is just going all over here. Okay, so that means 10 times 5, he spent 50 minutes walking. We know he swam some amount of time. We want to know how much time was spent swimming. All right, so we're going to call the amount of time swimming, we're just going to call that x. And it was 5 days. So 5 times x, the amount of time swimming, plus the 50 minutes of walking, equals 225 minutes. Go ahead and pause the video, solve this equation. Okay, let's check our answer. So we're going to start by subtracting 50. We get 5x equals, and then over here 5 minus 0 is 5. 2 minus 5 takes me into the negatives, so I'm going to borrow. 12 minus 5 gives me 7. And bring down my 1. 5x equals 175. So 175 minutes spent swimming in the week. Let's figure out how much that is per day. All right, so we are doing 175 divided by 5. 5 does not go into 1, does go into 17 3 times. 3 times 5 is 15. 17 minus 15 is 2. Bring down that 5. 5 goes into 25 5 times. Okay, so x equals 35 minutes. All right, let's take a look at our next one. Two equations are shown. Equation 1, negative 5x minus 4 equals 1.5. Equation 2, negative half times the quantity x minus 4 equals 1.5. Select each statement that must be true. X represents a negative value in both equations. X represents a positive value in both equations. X represents a positive value in one equation and a negative value in the other equation. The value x in equation 1 is less than the value x represents in equation 2. The value x represents in equation 1 is greater than the value x represents in equation 2. Okay, so we need to solve these and then figure out how many of these that are true. It says each statement, which means there could be more than one. All right, so we're going to start with equation number 1. Negative 1/2 x minus 4 equals 1.5. We do order of operations backwards. We're going to get rid of the minus 4 first by adding 4. Make sure when you have decimals that you add placeholder zeros as needed. So I changed that into a 4.0. So I have negative 1/2 x, negative 5/10 x, equals 5 plus 0 is 5. 4 plus 1 is 5. Okay, now I'm going to divide by that 5/10 x. Okay, when I'm doing this decimal division, I've got to move that decimal over. Move the decimal over. It is now 55 divided by negative 5. 55 divided by negative 5. 5 goes into 5 once. All right, that's 0. Bring down the 5. 5 goes into 5 once. Different signs, answers negative for multiplication and division. So we have x equals negative 11. That is my equation 1. Equation 1, x equals negative 11. All right. Now I'm going to do the next equation. We'll see what that one equals. Negative 1/2 times the quantity x minus 4 equals 1.5. Okay, got to do distributive property here. Get rid of that parentheses first. Negative 1/2 x times x is negative 1/2 x. Negative 1/2 times negative 4. Negative times negative is positive, so I'm going to put a plus. If it was 5 times 4, it would be 20. But I have one decimal here, so I have one decimal here. It's really like 2.0 equals 1.5. Okay, now I've got to get rid of my plus 2. I do that by subtracting 2. So I'm subtracting 2.0. 2 minus 2 is 0. I'm left with negative 1/2 x equals, over here, different, if I do boom, boom, different signs, find the difference. I need to put the one with the greater absolute value on the top. Okay, I do need to borrow here. 10 minus 5 is 5. 1 minus 1 is 0. Bring down the decimal. I had more negatives, so my answer is negative. Negative 1/2 x equals negative 1/2. We divide negative 1/2 on both sides. We're dividing by a decimal. We've got to move it over, move it over, move it over. It turns into negative 5 divided by negative 5, which is a positive 1. X equals positive 1. Okay, so now let's see which statements are true. X is negative in both. No, it's only negative in one. X is positive in both. No, it's only positive in one. F represents a positive value in one and a negative in the other. Okay, yep, see, that's correct. Let's see if the other ones are correct. The value X represents in equation 1 is less than the value in equation 2. Well, yes, negative 11 is less than positive 1. So that's true. The value X in equation 1 is greater. No. All right, so we have these two. All right, and finally, we're going to take a look at inequality problems here. Inequalities are statements that two things are not equal. Equation says they're equal, inequality says they're not. Here's a chart with some symbols and key phrases that mean the different things. So here's less than, fewer than, below. The sign means greater than, more than, or above. This sign means less than or equal to, at most, or no more than. And then this sign is greater than or equal to, at least, or no less than. Sometimes people think less than looks a little bit like a sloppy L if they're having trouble picturing which sign goes with each thing. When we graph an inequality, we need to have a number line. The number part of the inequality is circled. So x is greater than 3, there's a circle on the 3. If the inequality is a greater than or a less than, it's an open circle, which is a circle that's not shaded in. Then the number line where the answers could possibly be shaded in. When it could be equal to that, that's when we have a closed circle. If it can equal 3, the circle's closed. And then possible solutions are shaded. X is greater than 3. Numbers that are greater than 3 are shaded in. X is less than 3. Numbers less than 3 are shaded in. It's shaded in an arrow because that answer would go on for infinity here. Okay. One trick to help you with your graphing, if the variable comes first in your statement, that inequality sign does point the direction that you are shading. That only works if the variable comes first. Okay, so our inequality rules. We solve the same way as equations. If you multiply or divide by a negative number, flip the inequality sign. Otherwise, keep the inequality sign the same. All right, so for example here, if I have 2x plus 4 is greater than negative 6, I start by doing order of operations backwards. I get rid of that plus 4 first by subtracting 4. So I have 2x is greater than negative 6 minus 4. I can do boom, boom, and make that negative 6 plus negative 4. That's negative 10. When I divide by positive 2, I get x is greater than negative 5. I divided by a positive number, so my inequality sign stayed the same. Let's look at this one. Negative 4x minus 3 is less than 13. I start by adding 3 to both sides to get rid of that minus 3. Get negative 4x is less than 16. To get rid of the times negative 4, I have to divide by negative 4. When I divide by a negative, my inequality sign relationship changes. So my inequality sign changes too. X becomes greater than. And then the answer is negative 4. All right, let's look at our last question here. Consider the inequality 5x is less than 30. Part A, Natalia says that any value of x less than 25 makes the inequality true. Use a specific example to disprove Natalia's statement. Explain why your example disproves her statement. Enter your example and your explanation in the space provided. All right, so let's see. Any value of x less than 25 makes it true. So let's pick something that's less than 25, but easy to work with. I'm going to pick 10. Let's see if that would be true. 5 times 10 is less than 30. 5 times 10 is 50. 50 is not less than 30. Okay, so then I can explain why I do it. For time's sake, I won't write the whole thing out, but I multiply by 10, I get 50, which is greater than 30. All right, and then for part B, describe in words all values of x that make the inequality true. We've got to solve it. 5x is less than 30. To divide by 5 on both sides, we would get x is less than 6. So our answer here is all values less than 6 make it true. So every value less than 6 would make this true.